All right, so this is the last question, and to be honest, it's very tricky. I'll try to solve it, but optional problem, falling problem will not count against you. So if it is not against, like you may leave this blank, so that's good thing. But yeah, I'll try to solve it and try to explain it as much as you can. But yeah, it does have to deal with a lot of angles and a lot of mathematical stuff. All right, so it says two rays traveling parallel to the principal axis. We can see that strike a large plano-convex lens having a refractive index of 1.6. Right, so refractive index is given over here for the lens. The figure shows that the rays are incident on the flat side of the lens, right? We can see that, and exit through the curved convex side, right? So one side is flat, the other side is what you can say it's curved, right? It's convex. If the convex face is spherical, a ray near the edge does not pass through the focal point. So you can see the ray is doesn't pass through the focal point, right? They are moving in a different direction. They are not concentrating at one point. If this face has a radius of curvature of 21.5, so radius of curvature is given over here, which is 21.5, right? And the two rays are h1 of 0.512, h2 of 10.1 from the principal axis. Right, so one of the rays is at a height of 0.512, the other one is at a height of 10.1 centimeters, right? Uh, from the principal axis, calculate the difference in position when they cross, right? So you have to calculate this delta x. Okay, so I'm gonna start solving it out. I have understood it now, so let's see how it goes. Okay, so from the figure we can say that the first ray, right? So you know probably that theta phi 1 is sine inverse of height 1 over the radius of curvature that we have, right? That will give me the first angle that I'm trying to strike the ray with, right? So theta 1 is just I have applied the maths, right? Radius of curvature is given, r is given, height is given. So that's a triangle, and I'm trying to figure out the length over there, third length of the triangle. So that should give me sine inverse of height 1 was 0.512 divided by radius of curvature is 21.5. Okay, so that will give me the first angle as sine inverse of 0.512 divided by 21.5. It's telling me that the first angle turns out to be phi 1, which is 1.3645 degrees, right? Now that's our first angle at which we are trying to strike uh, the ray. Now we need to find the angle at which it actually leaves the ray, right? So we know that the refractive index was given over there in the question, which is 1.6. So now I'm going to use the Snell's law, which says that the first refractive index sine of theta 1 should be equal to the refractive index of second should sine of theta 2, right? So I'm going to figure out the theta 2 over here, right? So the formula would become that theta 2 is basically, I would say sine inverse mu 1 sine theta 1 over mu 2. Yeah, that's all. So I can write it as that theta 2 would be sine inverse. I'm going to put the values. The first mu 1 was 1.60. It's given in the question. Sine of my answer, which is 1.3645 divided by theta 2 is nothing, but it's like mu 2 is nothing, it's in the air, right? So I'm gonna put a 1 in the denominator over here, that because it's in the air. Okay, so that's the formula that will give me my theta 2 at which I'm leaving. So the angle at which I'm leaving is sine inverse 1.60 times sine of 1.3645 divided by 1. That would give me an answer of theta 2 as 2.1835, right? So I've got two of my angles over there, right? Theta 1 and theta 2, the one which is entering, the one which is leaving. So in order to calculate the change in the angles, I'm going to do the difference. I'm going to call it as a phi. So I'm going to say it's theta 2 minus theta 1. So that's 2.1835 minus 1.3645. And that will give me minus 1.3645. 0.8190. So I'm getting an angle difference of 0.8190 in between the portion, right? All right, so that's first part of the question. That's the angle which is it's now moving now, right? So if I can see over here, um, so I can make a triangle over here, probably like this. If this is a theta, the tan theta is what basically perpendicular upward the focal distance, right? So this is my h1, this is my focal distance over here, which is what, f1. So I should probably make it something like this. So this is my f1, this is my angle that I just figured out, phi, at which it's coming down, and this is my h1, right? So in order to calculate this f1, I need to solve this triangle, which turns out to be what? Hi and f1 turns out to be the tangent formula, tan theta. Okay, so tan theta is basically what, h1 over focal 1, at which it's trying to hit the focal length. That would become as, I'm going to get the answer for the h1 from here, because I don't know that, sorry, f1 from here, because I don't know at which I'm hitting it. So f1 would be h1 over tan theta. H1 value, I already know what was that. It was 0.512. So 0.512 divided by tan theta. That would be, the theta is basically your phi, right? It's, I'm gonna say it's tan phi, tan phi. So it's tangent of 0.8190. So this will give me the focal length distance, which is 0.512 divided by tan 0.8190. All right, so I'm getting a distance of 35.816. Now that is basically my vertical distance, right? So I have to calculate the horizontal distance. So for the horizontal distance, I'm going to use the for horizontal distance. I'm going to use the formula that x, let's say it's my horizontal distance, the total distance minus the basically the perpendicular one, right? Which if you apply the Pythagoras theorem, it will turn out to be r square minus h1 square, right? It's nothing, it's just the hypotenuse square is perpendicular plus base square. So I just moved it all and make it simpler directly. So x would give me r, what was the r? It's a lot of work in this question. 21.5. So 21.5 minus r square, that is 21.5 square minus h1. What was the value of h1? The value of h1 was 0.512, I think. Yeah, 0.512 square. So let's calculate this horizontal distance. That turns out to be 21.5 minus root of 21.5 square minus 0.512 square. I'll do it again. Root of 21.5 square minus 0.512 square. 21.5 minus answer. All right, so I'm getting a very small answer of 6.09710 power -3 centimeters, since I've done everything in centimeters. Right, so that is my basically my distance of x so far, the first distance. So in order to find it from the position, from the vertex position, I would say from vertex position x1 at which it's striking the focal length, that would be your focal length minus the one which we have calculated x, right? So my focal length was, I just calculated over here, was 35.816, I think so. Yeah. F1 was 35.816 minus X is now 6.097 10 power minus 3. So that will give me the first spot as 35.816 minus answer. That is 35.809 centimeters. All right. So after a lot of hard work that All right. So after a lot of hard work that we have done, this is the distance that we calculate for x1, right? That's the first distance from this point to here. Now we have to do the, or sorry, about this one, the second. Yeah. So now we have to do exactly the same method with the same formula for the second ray, so that we can reach to this point and then we can subtract the two. So I'm going to pause this video over here. I'm going to continue in the next one because I have the recording time slot maximum of 15 minutes. So I'm going to stop it over here. This is the first answer.